35 degrees Celsius to 42 degrees Celsius, or from 94 degree F to 108 degree Fahrenheit. Then there is the reading of a clinical thermometer. How do we read a clinical thermometer? What we do is that before the use of thermometer, wash the thermometer properly. It is better to use an antiseptic solution rather than ordinary water. Hold it firmly and give it a few jerks. You maybe hold it like this and you like this. If you've seen it. Why? Is because we bring the mercury level, and the mercury level has fallen or risen, okay, to make it to bring it back to the normal level. We give it a few jerks. Then it will bring the level of mercury down. Ensure that it falls below 35 degrees Celsius. We ensure that it falls below 35 degrees Celsius. Now place the bulb of the thermometer under the tongue. We place the tip, okay, or the bulb under the tongue or under the armpit. Then after 1 minute, take the thermometer out and note the position of mercury on the scale. You leave it there for 1 or 2 minutes, take it out and check. This mercury will come and set on a scale. Okay, so that will tell you the body temperature. Okay, this is how we read a clinical thermometer. Emma and Anna, videos on please. Now, next we have laboratory thermometer. To measure the temperature of other objects, there are other thermometers, such as a laboratory thermometer. Laboratory thermometer consists of a long, narrow glass tube. The lower end is like a bulb. This tube contains mercury or alcohol and it is sealed. Its upper end is sealed. The glass tube is kept in ice cubes. The point in the tube where mercury becomes steady after getting cooled is marked as 0 degree Celsius. Now the tube is kept in the steam of boiling water and the mercury starts to expand inside the tube. The point in the tube where mercury becomes steady is marked as 100 degrees Celsius. The intervening space between the 2 points is divided into 100 equal parts. Okay, we can say that it is divided into 100 equal parts from 0 degrees Celsius to 100 degrees Celsius. Thus, the measure of each small division is 1 degree Celsius. Generally, range of this thermometer is minus 10 degrees Celsius to 110 degree Celsius. The range, okay, and division is every small division is 1 degree Celsius. This very small divisions you can see. Okay, 1 degree Celsius they measure up to. Okay, now so two important things that you have to remember about this laboratory thermometer is that it is kept in ice cubes, and the point where in the tube where mercury becomes steady after getting cold is 0 degrees Celsius. And when it becomes steady, when we put in the steam, that point is 100 degrees Celsius. Okay. Now, precautions. The laboratory thermometer should be kept upright while using. Upright means like this, okay, in a standing position. Then the bulb should be surrounded from all sides by the surface of which the temperature is to be measured. Okay. The bulb should be surrounded from all sides, means that it should be completely immersed in the substance whose temperature we are measuring. Completely immersed in the substance whose temperature we are measuring. And then the bulb should not touch the wall of the container. Okay, like the bulb should not touch the,
Ma'am, not even the bottom part, right?
not even the bottom part. Bottom part, like sometimes it can.
No, ma'am, like normally when I've seen, like normally you keep the thermometer on a clamp, so it just
Yes.
hangs on the
Mhm.
solution.
Yes, yes. It is kept on a clamp, so it just hangs. Isn't even like submerged, but it hangs in a position.
It's because if it touches the bottom, ma'am, all the heat, like all the heat of the solution, will get transferred to the bottom because of the particle theory, or I don't know exactly. And because it's made of glass, it start to get hot. And when the thermometer touches the bottom, it will receive that heat and not the solution's heat.
Mhm. Yes, Abraham, that is right. It's a clamp is used to hold this. Okay, a clamp and a clamp stand is used to hold the thermometer, so that it is like not fully, its bulb doesn't touch the bottom. Okay, and it just only gets submerged in the substance from all sides. That is right. Now, in text questions 10.1, what is heat? Can anyone unmute and define what is heat?
Ma'am, heat is an energy.
Heat is an energy, yes.
It's a form of energy which is which is
Ma'am, can I say?
Yes, you can say.
Heat is the form of energy that is sometimes transferred between two substances at different temperatures.
Transferred between two substances. Yes, we can say that. Transferred from one substance to another.
Yes, ma'am. That's what I wrote in the book.
Or mostly it is like in one substance also, in one object or in one matter also, the heat energy transfers or like moves from in the same object from one part to another, because because of the molecules present in that subject. Because of the molecules present in that subject, heat energy flows, okay, in the entire object, and after that it also flows from one body to another. Okay, both the things happen, and very important is that heat is an energy. Okay, heat is a type of energy related to the motion of molecules of a substance. Motion of molecules of a substance. Okay, like when these molecules move in a substance, that only helps in the transfer of heat to like I gave an example of an iron rod. Okay, we we light a fire on one end. First, this end will become red hot, and then slowly, the whole rod will become red hot. This part will become hot first, and then it will move to the rest of the rod slowly. Okay, this is because of the molecules present, the molecules of the rod. Okay, which helps in traveling of this heat. Okay, the heat travels through the molecules to the rest of the object. Okay, if I increase this flame, the rod will become red hot faster, right? Because rise in temperature leads to increase in the speed of the molecules, okay, through which heat will travel. If I decrease this flame, then the rod will get red hot very slowly, because the speed of the molecules will also decrease. because the temperature decreases. When the temperature decreases, speed of the molecules decreases. Okay, so this is related to that. Which type of proportion is it between this speed of molecules and the temperature? Which type of proportion is it between the speed of molecules that I just explained and the temperature?
Ma'am, direct.
Yes, direct proportion. Why? Because when we increase the temperature, speed of the molecules increase. When we decrease the temperature, speed of the molecules decrease. It is a direct proportion. Now, we have like true or false. Temperature of an object decreases on heating. True or false?
False, ma'am.
False. Next one. Heat cannot be converted into energy. True or false?
False, ma'am.
Yes. False. Then we can measure the temperature of an object by touching it. True or false?
False.
False. Clinical thermometer contains mercury. True or false?
True. Depends
Mm-hmm.
on which one.
True. Mm-hmm. Now, Emma, can you hear? Can you answer the fifth one? The glass tube of a clinical thermometer is kinked near the bulb. Is that true or false? Yes, Emma. Can you hear? Are you able to hear me?
Yes, ma'am.
Fifth one, the fifth point. The glass tube of a clinical thermometer is kinked near the bulb. Is that true or false?
Ma'am, false.
False. Sure, is it false?
No, ma'am. True.
Abraham?
No, false, ma'am. Laboratory. Wait. Ah, ma'am, it's true. No, wait, it's true.
Yes, it is true. Okay. It is kinked near the bulb. The laboratory thermometer contains water. True or false?
Ma'am, no, can I say?
The laboratory thermometer contains water. True or
Ma'am, definitely false.
false? Yes. Then you have a diagram of a clinical thermometer. After that, we have propagation of heat. Okay. Propagation basically here means transfer of heat. Okay, or displacement of heat. What happens when we pour hot tea in an empty glass of steel? The glass becomes hot. What happens when a metallic rod is heated near one of its end? After some time, another end of this metallic rod also becomes hot. Keeping the hot tea filled mark for some time, the tea cools down and our body starts getting warm when standing at a distance in front of the fire. When we stand in front of the fire, okay, our body starts to get warm. Now, these actions show that heat flows from one object to another. Heat is flowing from one object to another. Like the iron rod, one end I'm heating, the other end will also after some time become hot. Okay. Why? Because the heat is flowing in it. Okay, the heat is transferring to it. If I'm standing near a fireplace, so after some time my body will start feeling warm. Okay, why? Is because from there, from the fireplace, heat has been transferred to me. Okay, heat has been transferred to our body. Now, These actions show that heat flows from one object to another, from one place to another, and from one part of the object to another. Where does heat flows or how does heat flows from one object to another, one place to another, and one part of the object to the other? This process of transfer or displacement of heat is called propagation of heat. Okay, propagation of heat. We say that this is propagation of heat. Now, let us understand how does heat propagate. Take two rectangular pieces of iron or any metal of same size. Heat one of the pieces for a while. Now place the second piece above or close to the hotter piece. After some time, find the temperature of both pieces. You will observe that the temperature of the second piece increases. What does this conclude? The propagation of heat between two objects is due to the temperature difference. The heat always flows from the hotter object to a colder object, from a hotter object to a colder object. Okay? Okay. So if we like blow on our hand like this, okay, or one hand and place it on our cheek, okay, what will happen? That when we blow on one of palm, okay, it'll become hot. When we place it on our cheek will also become slightly hot for a little time, right? We do that sometimes in winters because our cheek is cold, right? In winters this portion becomes cold, so we blow on our hands and place it on our cheek. What happens is, from the heat from the palm of our hand um, transfers to our cheek, and our cheek feel warmer, right? So this is also another example of transfer of heat. Okay, why? Is because our hands is a warmer object and the transfer is taking place to a colder object, that is our cheek, because heat always moves from a hotter object to a colder object. Now, another activity is dip one end of the spoon of steel in boiling water. What happens if you keep holding the other end? After some time, the other end also becomes very hot. Okay, like we're stirring something and cooking. Okay, if you keep cooking a very hot thing, the first this part becomes hot, then slowly the heat rises, and this part where we are holding also starts to become hot. Okay, how does that happen? Because each substance is made up of molecules. Each substance is made up of molecules. The temperature of the tip of spoon, which is in boiling water, increases. Hot molecules transfer their heat to neighboring molecules, very hot molecules, they transfer their heat to neighboring molecule. These molecules transfer their heat to their neighboring molecule. Thus, heat reaches the end of less temperature from the end of high temperature, and after some time the other end of the spoon becomes hot. This method is called conduction. This method of heat transfer, when heat transfers through the molecules, okay, like one molecule to other, the first molecule passed it to the second, second to the third, third to the fourth, fourth to the fifth. I have 10 molecules in my object, and fifth to sixth, sixth to seven, seven to eight, eight to ninth, nine to ten. Tenth is the end part of the object. So all the molecules will pass the heat on till the entire object will get hot. Okay.
Ma'am, is it the reason cause because when a substance is heated up, ma'am, it passes through the entire molecules because when the particle acquires energy, then after
Hmm.
it acquires the energy, it will pass it on to another molecule because another molecule that's thus making the entire thus spreading out the entire energy. It won't pass it on forever.
Yes, Abraham, that is right. It
If
like
I, if I put a hot spoon in hot water, it would pass on the entire energy in the spoon, and then some energy would be passed to my hand.
yes,
But
our
ma'am,
hand.
it won't completely go all around my body, ma'am. just because
Mhm.
of one hot spoon.
Yes, that is right. Some of it will be passed to your hand, but it all of it will not go like through around your body. Okay,
Because ma'am,
inside your
there
body.
has to be that much of energy in the heat for
Mm.
it to be passed on
Mm-hmm.
and
Yes. Yes.
stored in chemical bonds.
Yes,
Ma'am,
Abraham. Yes, Anna.
I have a question.
Yes.
You said that hot things can become cooler and cooler things can become hotter in the
Mm-hmm.
previous thing. So I was wanting to ask whether you said that hot things can become cooler, but can we heat the hot things more? Can we heat them up more and make them?
Um.
Ma'am, can I answer the question?
Yes, Abraham.
So Anna, basically you can heat up a hot thing like to how much ever heat you want, but after some degree or some amount of heat, the hot thing will start to deform or start to burn. Like plastic, if you heat the hot thing up, it will start to burn. Like some plastics, the ones that do not that set and then you cannot thermoset. I can't remember. So, and then some when you heat them up, they start to melt and they start to deform. Like some, like suppose you heat metal up to a very high temperature, the particles start to gain so much of energy that they start to get loose. They start to break all the everything that's keeping all of the forces keeping them in place, and they start to get loose. That's why they start to become into a liquid. But so you cannot heat, and after some time the whatever you're heating up will turn into a blob or something, so it's not possible to heat it. So there is a limit, and some materials will just behave different, like carbon.
Anna, is it clear now?
Yes, ma'am.
Okay. Now, some energy, like we are talking about energy, how like heat energy does not pass through our entire body if it is not enough, like through the spoon. Okay. But if like we are sitting in front of a fire for a long time, then it is possible that heat energy will pass in our entire body, and our like whole body will feel warm. Why? Is because our body temperature is lesser than the temperature of the fireplace. Okay, so the temperature from the fireplace, the heat from the fireplace will transfer to our body because heat moves from a hot body to a cold body. Okay, and then we will feel warm. So that time, like the heat energy travels in our entire body. But also, like if we take an example of electrical energy travels very fast. Okay, and it sometimes travels through our entire body. If we get a current, if we get a shock, okay, it travels. The electric energy travels through our entire body. Okay, but heat energy, it has to be that much of energy to travel. Okay, then you have an activity. Heat water in a small pan or a beaker. Collect some articles such as a steel spoon, plastic scale, pencil, metallic rod, etc. Dip one end of each of these articles in hot water. Wait for a few minutes, touch the other end. Enter your observation in the following table. So you have to take what will happen if you put plastic scale in hot water. Does the other end get hot or not? Pencil and metallic rod. Okay. Now you will
Ma'am,
yes,
you can answer this verbally.
yes. We can answer just verbally
Only the
that
metallic rod will get heated up. All the rest of the others, because they're not metal except for the steam spoon will not get heated up. Like the plastic scale will not, and so will the pencil. They may become the plastic scale may become a little hot.
Hmm. Yes, Abraham, that is true. The materials such as iron, steel become hot, but other materials like pencil, wood, and plastic do not get hot easily. And this is because the materials which allow heat to pass through them easily are called conductors of heat, such as aluminium, iron, and copper. And the materials which do not allow heat to pass through them easily are poor conductors or insulators of heat, such as plastic and wood. Plastic and wood are insulators, that is, they do not allow heat to pass through them easily, whereas aluminium, iron, copper, they do allow, they are conductors of heat. Okay. Take a tumbler, fill it with water. Wait till the water in the flask is still. Place a crystal of potassium permanganate at the bottom of the flask gently. Now heat the tumbler slowly. What do you observe? The colored steams arising from the surface of the water. What did you see? When water is heated, the water near the flame gets hot. Hot water rises up. Gets hot. This is gets hot. Um, Hot water rises up, the cold water from the sides come to take its place. This water also gets hot and rises, and the water from the sides moves down. This process continues till the whole water gets heated. This process, or this mode of heat transfer, is known as convection. Okay, convection. Do you know because like this water when it is heated, the water that is near the flame, it gets hot and rises. So the water at the sides comes to take its place. This water also, when it comes to take its place, it gets heated up and rises. So the water level from the sides slowly becomes less. When evaporation takes place, when this evaporation after on heating up is taking place, the water slowly on the sides is rising up and the level is dropping. Okay, and it happens until the water becomes half or less than half, even like quarter of the quantity which was there before. So when this method, but we can see that heat is getting transferred, right? In this process, the heat is getting transferred. Okay, it continues till the whole water gets heated, and this mode of heat transfer, when this happens, is called convection. Okay, it's called convection. How does heat transfer in the air? The air near the heat source gets hot and rises. The air that is near the source of the heat gets hot and rises. The air from the sides come in to take its place. In this way, air gets heated and air also gets hot. Thus, the process continues to take place. Okay, thus the process continues to take place. Now, we have applications of convection in daily life. Chimney, smoke and hot gases from homes and factories rise up due to convection. Smoke and hot gases from homes and factories rise up due to convection and get out through the chimney. Okay, and convection also happens in ventilators. Okay, in ventilators also, in the center part, they I think they are heated. I don't really know how this heating works in a ventilator, but yes, the center part gets heated, and then it comes from the outside portion. Okay, the cold air
Ma'am,
in the center.
ma'am, ventilators like in AC, right?
Mm-hmm. Yeah, ACs and all. Now,
So, ma'am, I think it uses heat energy. So, like, when it gets the air in, ma'am, it like uses the heat and it because for an air to become cool, it needs to subtract the heat energy. So
Mm-hmm.
it subtracts the heat energy from the air, and that's why whenever you stand out of in the AC or something like that, like the unit that's at the back of the building, you'll always feel hot air coming out your face. So
Mm-hmm.
yeah, and it heats up that and it gives it to the other
Yes, Abraham. That is
somehow.
well.
That's
Yes.
why it must be using heat.
Mm-hmm. It must be using heat. It uses heat. Yes. Now, another activity. Light a candle. Keep one hand above the flame, another hand on the side of the candle. Do your hand feel equally hot? No. Which hand will feel hotter? The one that is on the flame. Here, the air above the flame gets heated by convection. Therefore, the hand above the flame feels hot. On the sides, however, there is no convection and air does not feel as hot as the top. When we come out in the sun, we feel warm. How does the heat from the sun reaches us? It cannot reach us by conduction or convection because both require a medium, a direct medium, and there is no medium such as air, such as air in most part of the space between the earth and sun. Hence, from the sun, the heat comes to us by another process, which is known as radiation. Which is known as radiation. Okay. Now, the transfer of heat by radiation does not require any medium, okay, any medium, but directly the heat is transferred from the source to our body. Okay, when we sit in front of a room heater, we get we get heat by the process of radiation only. Okay, our body too gives heat to the surroundings and it from receive it receive from it by radiation. A hot utensil kept away from the flame cools down as it transfers heat to the surroundings by radiation. It means that all bodies radiate heat. When this heat falls on some object, a part of it is absorbed and a part of it is reflected. I explained this to you. When radiation is falling on an object, okay, or when heat is falling on an object in the form of radiation, some of it is absorbed and some of it is reflected. Okay, the temperature of the object increases due to the absorbed part of the heat. Now you have understood that is why you're advised to use an umbrella when you go out in the sun. Okay, do you have you seen like umbrellas get heated up sometimes, like little bit they get heated up under like a very high sunlight? That is because they absorb some of it absorbs like it absorbs some of the sunlight and the rest is reflected. Okay. Now break till 8:20. Okay. Break for like 2-3 minutes and then we're going to start maths. Hi Joshua, good morning.
Hi, ma'am. Good morning.
Good morning. Okay, let's begin. Now, yesterday we were talking about one question about Karan and Ahmad. Okay, and today we will work on it. What happened was that they were together completing a work. Karan and Ahmad were together completing a work in how many days? They worked together for 6 days. Okay, Karan could complete that work in 15 days. 15 days, and Ahmad could complete in 20 days. They worked together for 6 days. Then Karan left. So, how much time Ahmad will take to complete the work? How much time Ahmad will take to complete the videos on, please? Videos on. Abraham Emma, videos on. So, Karan could complete the whole work if he's doing alone in 15 days, whereas Ahmad in 20. They worked together for 6 days, and then Karan left. Okay, so we have to find how much time Ahmad will take to complete the work. How much time Ahmad will take to complete the work? Now, Karan's one-day work will be 15 days he's taking to complete the whole together. His one-day work will be Karan's one-day work will be. What will be the fraction? Tell me. What's going to be the fraction I've taught you? One upon 15. When we are finding for one day or one day or one part, 1 upon 15. Okay, remember this. Then Ahmad's one day work will be Ahmad's one day work will be, what will it be? One upon 20. 1 upon 20. Now, Karan's one day work 1 upon 15. Ahmad's one day work 1 upon 20. If they work together, let's find out if they work together, how much will they complete in one day? Okay. In one day together, they will do they will add it. Okay, they will add it 1 upon 15 plus 1 upon 20. Add this and add this and find out the in one day both together will do how much work. Add 1 by 15 plus 1 by 20 and tell me. Joshua, you know how to add? Take an LCM of 20, 15, and 20. See what you know
Pardon,
how
ma'am?
to.
I didn't hear you the first time, ma'am.
Okay. Do you know how to add a fraction?
Maybe. I don't really know.
You don't really know. Okay. So I'm doing it. See, the first thing when we are adding a fraction is we draw a line below it. Okay. And then we check for such a number who is coming in the table of 15 also, in the table of
Ma'am,
20.
ma'am,
Yes. Yes.
it's 60, ma'am, but when you simplify it, you get 4 upon 60 plus 3 upon 60. And ma'am, this number, when you add it, you're getting 7 upon 60.
7 upon 60 is correct, Abraham.
Then ma'am, how do you simplify it?
You don't have to simplify it. We'll take it in fraction only. Okay, don't worry. 7 upon 60 is correct. We are going to use 7 upon 60. Okay, see, Joshua, now 15 and 20, if we take a look at, we have to below this line, we have to write a number which will come in this denominator also, in this denominator also, which will come in both the tables. So 15, then 30, then 45, then 60, whereas 20, then 40, then 60. 60 is a number which is coming in both the tables. So we've written 60. Now, how many times 60 is coming in the table of 15, Joshua? How many times? Unmute yourself.
Ma'am, can I say?
1 minute, Abraham. Unmute and say, Joshua.
4 times, ma'am.
Yes, 4 times. 15 is coming 4 times. So 1, look at the numerator 1 multiplied by 4. How many times 20 is in the table of 20? How many times 60 is coming?
In the table of 20, how many times 60 is coming? 3, ma'am.
Yes, 3. So 1 multiplied by 3. The numerator we will multiply. So 1 into 4, 4 ones are 4. 1 into 3, 3. So we have 4 plus 3 by 60. That gives me 7 by 60. Okay, 7 by 60. So 7 by 60 is the 1 day work that Karan and Ahmed will do together. How many days did they do together actually? Okay, 6 days. They did the work together for 6 days. Next step is
Ma'am,
we multiply.
how can
Yes.
7 upon 60 be the 1 day work?
How can 7 upon 60 be the 1 day work? Because first we found out individually the 1 day work. Okay, 1 day work 1 by 15 and 1 day work 1 by 20. Now both are doing together.
So ma'am,
Both,
7 upon 60 is the decimal of work they do one day. 7 upon 6.
yes,
The decimal, right?
7 upon 60, yes. But we are going to like this fraction form as it is 7 upon 60, not the like decimal or the reduced. Okay.
Yes, ma'am.
Now see, did you understand? Like, Karan was working 15 days. Karan was able to finish the work in 15 days, and Ahmed was able to finish the work in 20 days. I needed 1 day work of Karan and 1 day work of Ahmed. So Karan's 1 day work was 15 days he was taking in total. 1 day would be 1 upon 15. That is one part of the work that he did. Then Ahmed's 1 day work is 1 upon 20. Now together in 1 day, how much they are doing? Together, 1 by 15, 1 by 20. Together in 1 day, how much they are doing? So we add it 1 by 15 plus 1 by 20, that is 7 by 60. Now, now the question says that for 6 days they work together. For 6 days, so they work together. So their 6 day work, their 6 days work. will be 7 by 60 multiplied by 6. 7 by 60 multiplied by 6. Why? Because together they worked for 6 days. But we don't know how much work, right? We don't know that. We found out 7 by 60 together, they will work in one day 7 by 60. Now to find their 6-day work, we multiply it with 6. Okay, we multiply it with 6. Makes sense, right? Hope you are understanding. Emma, Abraham.
Yes, ma'am.
Okay. Joshua, little bit.
Yes.
Okay, it's okay. No problem. Now, 6 days work, we will multiply 7 by 6, 60 into 6. Cancel. Cancel it. 6 ones are 6 tens are. 6 days work is, their 6-day work is 7 by 10. Sorry. Their 6-day work is 7 by 10. Okay. Now we will find out their remaining work. We will find out their remaining work. Okay. So remaining work, that is what will we assume the remaining work is? We'll assume it to be 1. Okay. We will assume it to be 1. Okay. From this, like the total work we will assume it 1. Okay. From 1, we to find out the remaining work, we are going to subtract 7 by 10. Okay. Remaining work.
Ma'am, is the remaining work 3 upon 10?
Yes. Remaining work.
Ma'am, sir, we kind of use the unitary method. So we first find the work for one day of the entire of 60 days. Then we multiply that by 6 to find out how much work they did in 6 days. And then after that we subtracted to see we subtracted by one whole to see how much work is left.
Yes, Abraham. Okay. From one whole is my work, the total work. Okay. To find out the remaining work, I subtracted 7 by 10. 7 by 10 was done by both. Right, 7 was done by both in 6 days. So that I subtracted from one whole, which is my total work. Okay. Now I will get, after subtracting, I will get 3 by 10. Okay, I will get 3 by 10. Joshua, I want you to do this subtraction. Find out, put this 1 upon 1, and then do the minus. Okay, do the minus. Okay, now 3 by 10 I have. This is Ahmad's work. Okay, this is Ahmad's work that he has to do. That is remaining after Karan left. Ahmad has to do. After Karan left, Ahmad has to do this work. Okay. Now, so Ahmad, the question mentions that Ahmad does the whole work in 20 days. Okay. So that is the thing we are going to take and multiply the remaining work with. Okay. That he completes the full work in 20 days. So in 3 upon 10 days, he will complete how much? Okay.
So, ma'am, 6 upon 20. He has 6 upon 20 work left to do.
6 upon 20. 6 you're gonna get, Abraham. Only 6, I guess.
Ma'am, yeah, he has 6 days of work left to do.
6, yes. 6 days of work left to do. 6 days of work left to do. Because 3 upon 10 work is left. Okay. 3 upon 10 work is left. And he takes how much days? Ahmad takes 20 days. Ahmad takes 20 days to do it. So 3 upon 10 work in 20 days, how much he can do? Cancel and find out 3 into 2, 6 days. Okay, he can do the 3 upon 10th work in 6 days. 6 days he will take to do 3 by 10 work. That is the remaining work. 3 by 10 was the remaining. Okay. It's going to take him 6 days to do that work. Understood the question? Anna, did you understand?
No, ma'am.
Any doubt, Anna?
No, ma'am.
Ma'am, can you give us another question like this?
Hello.
Ma'am, can you give us another
Hello.
question like this? Yes, ma'am. Can you give us another question like this?
A question like this. A question like this. Yes, you can do a question like this. I'm going to give you a question like this. Yes, I can give you all another question. Have you all written this question? Done writing this question?
Ma'am, the homework
Yes.
will be exercise 7.5, right, ma'am? The
7
remaining
point,
questions.
yes, 7.5, the remaining questions. Almost done. Okay, Anna. Done. Okay.
Done, ma'am.
Done. Okay. Okay. Now, what we'll do is we are going to try one more question. We are going to try another question. Joseph and Reena, J and R completed a work in 12 and 24 days respectively. 12 and 24 days respectively. Okay. Both started the work together. Both started the work together. But J left 3 days before completing the work. 3 days before completing it. Okay. Now, remaining work was done by Reena. R did the remaining work. R did the remaining work. How many days? In how many days the work was completed? In how many days? In how many days the work was completed? So both R and J, J can do in 12 days, whereas R can do in 24 days. Okay. And both started the work together. But before finishing the work, J left 3 days before the work could be finished, and R only did the rest of the work. So now, how many days did it took for the work to be finished at the end? That you have to find out.
Ma'am, is the answer 5 upon 8?
5 upon 8. What answer, Abraham? The entire answer or
One of the after you multiply it by 3, is the answer 5 upon 8?
no?
No, ma'am.
First, what you did? Tell me the first step.
First, 1 into 22, ma'am. Then I double 12, so that gave me 2 upon 12. Then I plus 2 upon 12 with 1 upon 24 equals to 3 upon 24. Which then I simplified to equal to 1 upon 8. Then 1 upon 8 multiplied by 3, 3 ones are 3, 3 upon 8. Ma'am, is that wrong?
The first step is right, Abraham. 1 upon 8 is correct. Okay. 1 upon 8 is correct. And the work finished by Reena in 3 days is gonna be 1 upon 8 multiplied by 3. So what you're getting?
Ma'am, I got 3 upon 8.
You got 3 upon 8. Okay. All right. Now,
Ma'am, is that correct?
is that correct? I think it's correct, Abraham.
So can you just show, ma'am? So I just had to multiply 3 by 1 because I could not simplify.
Mm-hmm. It will be multiplied like that if you're multiplying it. The work completed by both Joseph and Reena will be 1 minus 1 by 8, that is 7 by 8. Because we are finding out the work that both of them did. Both completed the work in 7 days. Mm-hmm.
Ma'am, 7 by 8, sorry.
7 by 8. Uh, J and R's. J and R's. 1 day work. 1 day work. We have 1 upon 12 plus 1 upon 24.
Ma'am, so
Yes.
J is left to do 24, 3 upon 24 work.
Yes.
Is that the answer?
No. It will be like this is one answer. Okay. That is their 1 day work. 1 upon 8 is their 1 day work. Okay. Now the work finished by Reena in 3 days. Work finished by Reena in 3 days. By Reena in 3 days is gonna be 1 upon 24, that is Reena's part, multiplied by 3. Okay. Why are we calculating 3 days work? See, why are we calculating the 3 days work is because he left 3 days before completing it. J left 3 days before completing it. So those 3-day work I have to find for Reena because Reena alone did the 3-day work. Reena alone did that 3-day work. So I have to find out that in like 3 days, how much Reena alone did. So 1 by 24 is Reena's portion multiplied by 3 will give me Reena's 3-day work that she did alone. Okay, Reena's 3-day work
Ma'am,
that she did.
1 upon 8.
Yes, 1 upon 8.
So the answer is 1 upon 8.
No. We'll do further. Okay, we'll do further. Then we will see the work completed by both Joseph and Reena. Both Joseph and Reena. If we assume that um, the complete work is 1, okay, we'll find out the work done. Work done by both J and R. We will do 1 minus 1 by 8. Why
Ma'am,
is it?
1 upon
Yeah.
7.
Yes. No. 1 upon 8. Like you
Still
will
1
get.
upon 8. 1
Yes.
minus 1 by 8 is 7 upon 8.
7 upon 8. Good, Abraham. 7 upon 8. Why did you understand this portion? Are you able to understand why I did this step in red? This step in red. Yes. Work done by both G and R. Okay. Like see, there is the work. There is the work. Okay. Now, this much of it both did together. Okay. Then only 3 days work when it was left.
Ma'am, what did we have to
Reena,
exactly find out?
what did we have to exactly find out? We exactly have to find out that after this J left, R has to do all the work. Okay, R has to do all the work. Now, when R has to do all the work, how much time, in how many days, all the work will be completed? The portion which they did together and the portion that R has to do. See, look in this diagram that I have made below. Together they did this much portion, and R alone did this much portion because J left here. Okay, here J left, here, here J left. Okay. So the rest R had to do now. Now we have to find that this whole duration, how many days? How many days was the work complete? The whole thing. That we have to find out. This whole duration. That
So couldn't we
duration.
not just say 8?
Say again.
Ma'am, couldn't we not just say 8?
Could we not just say 8? We can say 8. Okay. But 8 is not the exact number of days. 8 is not the exact number of days. Okay, let's find out the exact number of days. I'm erasing this diagram. Okay, now see. Now, work done by both J and R, we are finding that. For that, the total work, this is the total minus Reena's portion, minus work done by Reena, will give us how much work both did, J and R. Okay, how much work both did. So first you can like write it down like this if you want to avoid the confusion. You can write it down like this. Work done by both J and R equals to total work minus Reena's work, R's work. Okay, total work is how much? 1 minus R's work is 1 by 8. When you solve this, you will get 7 by 8. Okay, how much? 7 by 8. Now, both completed the work in 7 days. Now I have the numbers. See. Now I have the numbers. Okay. Now we'll put the answer together. How? Both did the work in 7 days. This is gonna be 7 days. Okay, this is gonna be 7 days. 7 days. Okay, so look, both did in 7 days. And then Reena alone did for how many days? R alone did for R alone did for how many days? 3 days. The question is mentioning 3 days. So time taken to complete the work or total time. Total time. We will add both of them. Total time's got to be 10 days. This is my answer. Total time's gonna take is 10 days. Okay. See, once again, I will go over all of it, what we did from the start.
Ma'am,
Okay,
no need. It was very. I understood, ma'am. You just
You
basically found out that 7 days they did. Okay, and then 3 days Reena was left to do. So then 7 plus 3 is equal to 10.
Yes. Okay. See, we did J and R's 1 day work. Okay. J and R's 1 day work we have to find out. So we added both of them and found out that 1 day work was 1/8. Then we found out Reena, how much work was done by Reena in 3 days, because 3 days she was doing it alone. So how much she did in 3 days? So 1/24 was her portion multiplied by 3, 1/8. Now we have Reena's work for 3 days. Now we'll find out of the total. We'll finding the work that both of them did together. Both of them did together. So 1 was the total work. So for both of them together, to find both of them together, we subtract Reena's work from total work. From total work, I subtracted Reena's. Total work was 1. From that, I minused Reena's work, that was 1/8. I got 7/8, that is 7 days. Okay, we'll assume it as 7 days. So 7 days both worked together, and the question says Reena worked 3 days alone. So make a total 7 days together and 3 days, and after that he left. After that, J left, and R had to do the work for 3 days alone. So how much they did together? 10 days. Okay, 10 days they worked together. Now, able to understand, Joshua?
Sort of, ma'am.
Sort of. Emma and Anna, able to understand?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Okay, it's okay, like Joshua, if you are unable to understand the full thing right now, because this is one of the hard chapters that he joined in. Okay, so don't worry about it. We can work on this more when you practice. Okay, you will be able to solve. Okay, and I'll also do it with you. Okay, now see, Joshua, you have to practice some questions at home, and you have to check out what I have taught in class at home also. Okay, please make sure you all are doing a revision. Okay,
Okay, ma'am.
not only you, but everyone, Abraham, Anna, Emma. I want all of you to do a revision of whatever is taught in class at home. Okay, take out an hour. Okay, not like 4 hours, 3 hours, 1 hour. Take out 1 hour and go through whatever I teach in class, so that you will be able to connect more. Okay, so that you will be able to connect more, and it will, you will stay in touch. Then that will not happen that I moved on with with a topic and you all forgot it when I moved on. That shouldn't happen. Okay, so please connect and revise at home. Please do the homework. Try out like 7.5 questions only. Okay, tomorrow we will start a new exercise about distance and distance, speed, and time. Okay, we'll do distance, speed, and time
Ma'am,
tomorrow. Yes, Abraham.
ma'am,
Sorry.
ma'am, at the end of every week, ma'am, like suppose that
Mm-hmm.
like at the end of like every weekend, ma'am, because
Mm-hmm.
2 days we have like kind of like we don't have any classes, ma'am.
Mm-hmm.
Can you give us normal homework and like other 2 3 questions of questions from a different chapter like that we need to revise.
Mm-hmm. Yes, Abraham, I can do that.
Thank you, ma'am.
Okay. I can give you all questions from the chapters you need to revise, some extra questions and material. Okay. For today, prepare for tomorrow's test. Tomorrow, no class will be there because my exam is there tomorrow. I have to go to give an exam, so no class tomorrow. Okay. Joshua, we will meet Thursday. Okay. We'll
Okay,
meet
ma'am.
on Thursday. All of you, I'll see you all on Thursday now. Okay, please prepare for tomorrow's test well. And okay, see you all then. See you all then. Bye.
Bye,
Ma'am,
ma'am.
when will you be
Thank-
sending the test?
Morning. Tomorrow morning. You want tomorrow morning, right?
Yes, ma'am.
Tomorrow morning, I'll share.
Bye, ma'am. Thank you, ma'am. Bye,
Okay.
Anna. Bye, Emma. Bye,
Bye.
Joshua.
Anna, you are a silly girl.